I watched an employee at a hardware store point a first-time buyer straight at the biggest angle grinder on the wall. 9-inch disc, 15 amp motor, the works. Get the powerful one, he said. You'll never need to upgrade. The guy nearly bought it. He was about to spend close to $200 on a tool that most professional forums describe as something you need to be built like a heavyweight boxer to control comfortably. That exchange isn't an isolated bad recommendation. It's the default sales script for a category where the specs sound impressive and almost nobody selling the tool has to be the one holding it. Start with size, because that's where the confusion begins. Angle grinder size refers to the disc diameter, not the tool's overall length, and the most common size on the market, the 4.5 inch, exists for a reason. It spins between 8,000 and 12,000 revolutions per minute depending on the model. It weighs somewhere around 4 to 5 pounds, and welding forums with decades of collective shop experience consistently point new buyers toward it before anything larger. The 7-inch steps up to a 13 to 15 amp motor but drops to 6,500 to 8,000 RPM, and it requires 2 hands to operate safely. The 9-inch, the one that almost got sold to that first-time buyer, has been restricted or banned outright in a number of regions specifically because of the accident rate associated with it. And just to give that some context relative to the tool category as a whole, it's worth knowing a bench grinder is a fixed stationary machine, which is part of why handheld grinders in the 7 and 9-inch range carry so much more risk. Then there's amperage, which gets treated as a marketing number when it's actually the specification that determines whether the tool bogs down mid-cut. A 6 amp motor is fine for light work. Anything above 6.5 amps starts qualifying as professional grade for a 4.5 inch grinder, according to industrial suppliers who rate their own tools against that threshold. The reason this matters isn't abstract. A motor that stalls when it meets resistance is a motor that makes the operator push harder to compensate, and pushing harder into a stuck disc is the exact mechanical setup for kickback. Brushless motor models hold their speed under load better than brushed equivalents, which is worth knowing when you're comparing specs on the shelf. And if you're weighing cordless versus corded battery-powered grinders have gotten genuinely capable in recent years, though for sustained cutting work, a corded tool still maintains more consistent torque. Which brings us to the number that should actually decide whether you feel safe holding this tool at all. The Royal Society for the Prevention of Accidents tracked angle grinder injuries in the United Kingdom and found roughly 5,400 a year, making it the 3rd most dangerous handheld tool in the country. In the United States, the Consumer Product Safety Commission logs around 25,000 angle grinder injuries annually, and OSHA's data on kickback specifically states that 1 in 5 kickback injuries from grinders and saws is fatal, not 1 in 500, 1 in 5. None of that risk originates in the motor. It originates in a disc spinning at a speed it was never rated to survive, which is why every legitimate disc carries an EN12413 or ANSI B7.1 marking. EN12413 is the European safety standard for abrasive wheels, and ANSI B7.1 is its American equivalent. That marking has to equal or exceed the grinder's own spindle speed before the disc goes anywhere near the tool, and none of it matters if you're not wearing a face shield and safety glasses, because a disc failure at 10,000 revolutions per minute doesn't give you time to react. The disc type matters too, and the ratings apply across all of them. A cutoff wheel is thinner and designed for slicing through material. A flap disc is layered abrasive for grinding and finishing. A wire brush cup attachment is for surface prep and rust removal. Each one carries its own maximum RPM rating, and each one has to be matched to the spindle speed before it goes on the tool. That matching process is the same regardless of which disc you're using. Missing it is missing it. So here's where this actually lands on you, standing in the aisle deciding what to buy. The salesperson pointing you toward the biggest, loudest number on the box isn't wrong that bigger tools remove more material. He's just not the one who has to control 2 hands worth of 9-inch torque on your first week using it, and he's not the one whose kickback statistic gets logged if the disc to spindle math doesn't line up. The buyers who end up satisfied a year later, the ones welding forums point to again and again, didn't start with the biggest number on the shelf. They started with a 4.5 inch grinder in the 7 to 11 amp range, something like what DeWalt, Makita, and Milwaukee all make at that spec. Variable speed if the budget allowed it, and they learned to read a disc's rating before they ever pulled the trigger. They also made sure the disc guard was fitted and adjusted before every use, because the guard isn't optional equipment. The specific tool mattered less than the specific discipline of checking 2 numbers against each other before every single use. I think about that guy in the hardware store sometimes. Not because he made a mistake. He didn't buy the 9-inch in the end. A friend talked him out of it. I think about him because of how close it was. One employee, one confident sentence, and a $200 tool built for professionals headed home with someone who'd never held one before.